Hello everyone, we're going to be going over the graph of a rational function today. The first three problems are just simple one-part problems. The last three problems have 13 parts each. That's why this is such a short assignment. The last question was question 7, and just like I said on 5.3, it was over oblique asymptote, or it had an oblique asymptote on it, and you had to use synthetic division to find it. And synthetic division is not part of our course objectives. So I took that off to hopefully try and make this a bit more manageable, being so much material. Okay, so let's get started. Which type of asymptote will never intersect the graph of a rational function? So oblique and horizontal asymptotes can intersect our graph, like our actual graph. But vertical asymptotes, we know because how we find them is we figure out what cannot be included in the domain, what makes it undefined. So if it's undefined there, then there can't be a point on that graph, so it couldn't intersect it. So vertical is our ones that can never intersect the graph because at those points it is not defined. Find the domain of R, select the correct choice below, and if necessary, fill in the answer box with your choice. So when we're finding our domain, we take our denominator, because remember our domain is where our graph is undefined. Solve to figure out what would make that be 0, because if 0 is in the denominator, you can't have 0 there, that makes it undefined. If anything, at the end of this course, you'll know that 0 cannot be in the denominator. So when x equals 3, this is that vertical asymptote, and that is the value that cannot be included in our domain, cannot be included in the domain. So we're going to make our intervals -infinity to 3, unioned with 3 to infinity. -infinity to 3, unioned with 3 to infinity. The x-intercepts, so when we solve for our x-intercept, we set y equal to 0. So we'd have, where do I want to write this? 0 equals, and I'll set it up to the whole thing real quick instead of short-terming it. If I was just doing this, I wouldn't have put the denominator on it, because our first step would be, opposite of division would be to multiply. And when we multiply this, anything times 0 is 0 still. And anything divided by itself is 1. That's why, I guess that's one way to get rid of it. That's why we multiply by it if it's division, because inverse operations. Here we'd set both of those factors equal to 0. So I'm going to have 0 equals x, and then I'm going to have 0 equals x subtract 3. And since it's squared, we can leave that there. To get rid of a square, that one's already solved. We'll take our square root of both sides. So 0 equals x subtract 3. And then we'd add 3. Right here, this is kind of a trick, though. Because what is the one value that cannot be in the domain? 3. So this is not included in the domain. I'm going to write it right here. Not included in domain. I write so bad on these boards. So it's not included in the domain, so that one is not the answer. I don't know why I circled it. I'm going to mark it out now. This is the only one. So we're just going to put 0 in there. They just want it as an integer, so just put 0, not an ordered pair. So we're going to type 0 there. Okay. this part right here, they want us to find the y-intercept. When we're finding the y-intercept, we put 0 in for x. Go away. So remember, this function notation right here is our y, and then we're going to put 0 in for our x. 0 minus 1 over 0 plus 1 and 0 plus 7. And then we're just going to simplify this, so I'm going to go ahead, I'm going to write it right here because I'm going to run out of room. I'll have 28 times negative 1 over 1 times 7. So I'm going to have negative 28 over positive 7. Negative 28 divided by 7 is negative 4. And this one's multiple choice. Okay, now we're getting into those really long problems, 13 parts. There's 3 of these. So even though this is 6 questions, this is going to be one of our longer lessons. It does get redundant though, so like it asks the same thing, just a couple different ways on it. Follow the steps for graphing a rational function to graph the function r of x equals x plus 3 over x times x plus 11. If needed, first write the given function as a single rational expression, then factor the numerator and denominator of r of x. Select the correct choice, and if necessary, fill in the answer box. It cannot be factored further. It's already factored out. If this would have been x squared plus 11x, we could have factored the x out and factored it further. So this one, there's nothing I can factor further. Domain. So remember, when we're finding our domain, we take our denominator and set it equal to 0. So I'm going to take that, x times x plus 11 equals 0, and then set both factors equal to 0. This is when I need another board. I'm going to solve this one, so x equals negative 11. These two values right here are our vertical asymptotes. I'm going to save that. And by save that, I'm going to write it somewhere else, because we are going to need this. Our vertical asymptotes, I'm going to put ASY, is going to be x equals 0 and x equals negative 11. Because those are the two spots that are undefined in our domain, so that means they are our asymptotes for later. That looks a little rough up there. They want us to write this in interval notation. Remember, least to greatest, and you start at negative infinity. So we're going to go from negative infinity to negative 11 is smaller than 0, unioned with, then negative 11 to 0, unioned with 0 to infinity, because you're going to go from negative infinity to positive infinity. You just have to put your zeros in order. So I'm going to go ahead and get rid of this and this. And I have those right up there, so I'll get rid of those too. But let me type this part in. We'll keep going. I should have recruited somebody to come and type these in for me. Is a thought for future references. Okay. Right here they ask about lowest terms. Lowest terms would be if this one was x plus 11 up here, or if it was x times this, and I could cancel out. If something was the exact same in the numerator and denominator, we could simplify it. We can't. Locate the intercepts of the graph, select the correct choice, and if necessary, fill in the boxes. So we're looking for x-intercepts and y-intercepts. Let's go ahead and do y first. So we're going to set r of x as y, and then we're going to put 0 in for all of our x values. So 0 and then 0 plus 11 So this would be 3 over 0 times 11. Since there's 0 on the bottom here, this is undefined. So we have no y. So we're going to have to use b. Now then we need to check for our x-intercepts. So we're going to put 0 in for y and solve it. So let's do 0 equals, I said this in the last, not the last one on question 2. When we have this denominator right here, our first step, since it's all being divided by it, would be to multiply. So when I multiply this x times x plus 11 by 0, it's gone. So when you're solving for your x-intercept, you can just do the numerator. And then I'd subtract 3, so x equals -3. Okay, so my only intercept is -3 right here. And how do they want it? Integers, so just that. I do believe on this you really have to pay attention to how they want you to type your answers in, because I feel like somewhere they want an ordered pair. Determine the behavior of the graph of R at any x-intercepts. Select the correct choice, and if necessary, fill in the answer boxes to complete your choice. Okay, so our only x-intercept is what we just found, -3. So this is where, which lesson was it? We had to do, if it was positive, it touches, and if it's odd, like the degree is odd, the multiplicity, it crosses. So if it's even, it touches. If it's odd, it crosses. Do we have any exponents up here? No, so that means they're all 1. So that means it's all going to cross, and we only had that one intercept. So at -3, that was a lot. So we were looking for our multiplicities. Our multiplicities on all this, like the x plus 3 is 1, x is 1, and x plus 11 is also 1. So that's what happened there. Okay, vertical asymptotes, we have them right here. We have 0 and -11. We're going to have to do, our leftmost is going to be x equals -11. Our rightmost is x equals 0. Because we had to put them in order. Determine the hole if it exists. Holes are when things line up on the top and the bottom. We don't have that. None of these problems have it. So there's not going to be any holes in our graphs. Determine the behavior of a graph on either side of any vertical asymptotes. If any exists, select the correct choice, and if necessary, fill in the answer boxes to complete your choice. So this is that same thing. If it doesn't have, if it's not even, it's not going to both go to the same way. So all of ours cross. So one's going to go towards negative infinity and one side's towards positive infinity. I'm actually going to pull up the graph in a second so you can see that better. But you have to read these to be sure you click the right one. It approaches infinity on one side of the asymptote and negative infinity on the other. That is what we want, but this one has the two parts. So this would be if we had like this part was squared, if x was squared or x plus 11 was squared. So one of them would be both to one side and the other would cross. It approaches either infinity or negative infinity on both sides. So this is if you have that even multiplicity. This is our odd one. This is ours. How they want us to type on this one is we're going to do -11, 0, because they already have that x equals. Okay, now we're going to do our asymptotes. So we need to do the degree of the numerator and the degree of the denominator. And I have that paper pulled up, so let's go ahead and get our degrees. So the numerator, there's only one x up here, and there's no exponents, so the degree is 1. Our denominator, and remember they use m, there's two x's down here, so if I multiplied them, it would be x squared. So our degree is 2. So we have 1 and 2. Let's see which one that falls under. Boo. Okay, let me try and check it on here. I pulled up a different note for our next videos, but I didn't think it'd mess up that one. I need you to be full screen, buddy. So, X minus this one. Okay, so our N is 1 and our M is 2. So that means our numerator is less than our denominator because N stands for numerator, M is denominator. Remember, you either have horizontal or oblique, you don't have both. So our line is horizontal asymptote at y equals 0. So one horizontal asymptote, remember you have to type the equation, so y equals 0. And since we have a horizontal, we do not have an oblique because you have one or the other, not both. And then the graph of R intersects. So when you have they're asking if it intersects it. So we're going to set this right here. If we put 0 in for y, what would we get as our answer? I'll go ahead and work it, but this would be the same as finding our y-intercept, because if we're putting 0 in for y, we'd be figuring out what it is, so let's go ahead and do that. If we put 0 in for y and solve our graph, what would we get? This should look familiar. So a bunch of these, it copies itself, but you'll get used to seeing that. So if it's being divided by something, the opposite of division is multiplication. So I'd multiply 0 by x times x plus 11. When I multiply it by 0, it's still 0, and this would be gone. So 0 equals x plus 3. Then we'd subtract our 3, so negative 3 equals x. So our graph intersects the horizontal asymptote at a type and ordered pair. So this would be negative 3, and y is 0. Helps if it's in the thing. Okay, this part I think we're gonna go ahead and pull up the graph and look at it. So let's see, if I click here, we'll go to this one. I'm pulling up Desmos graphing. And our graph is x plus 3, x plus 11. So I'm going to use f of x instead of r of x. Equals x plus 3 over x times x plus. Make sure I typed it in right. Beautiful. Use the real zeros of the numerator and denominator of R to divide the x-axis into intervals. Determine whether the graph of R is above or below the x-axis by choosing a number in each interval and evaluating R there. Select the correct choice and fill in the answer boxes to complete your choice. So I'm showing you the graph. This is our full graph. They want us to split this graph into intervals. using our zeros. So we already had our intervals including our asymptotes. We just didn't have our interval including our zero, which is somewhere in there. Okay. So this interval was negative infinity to negative 11. And then our zero was negative 3. That's why that don't look right. And so this one would be from negative 11 to negative 3. And then here we'd have, I don't want to write them on different sides, but I'm going to get crowded right here. Negative 3 to 0. And then this is 0 to infinity. And what they're asking on this is it that interval above or below the x-axis? So I know it looks like these are, can I zoom in? That's at negative 3. I know this looks like it was like touching the x-axis, but it's going to get infinitely closer to it, but it's never going to touch or cross it. So this is all going to be below. Let me get my interval sign back up. So here is a below, and let's just move it to be below so that it matches up. Here, negative 11 to negative 3, that is all above the x-axis. Negative 3 to 0 is below the x-axis. And then 0 to infinity is above the x-axis. You can zoom in if you need to. And that's what they're asking for on this problem. So above the x-axis. We have them both, so we have to do both of them. They want us to use a comma. So it's above the x-axis, negative 11 to negative 3. And then it's also above 0 to infinity. I may need to split screen on this one to show y'all both at the same time. And then here it was below negative infinity to negative 11. And then it was negative 3 to 0 as well. And I think they want a comma and not a union there. We're going to find out. Yep. Then, one thing about pulling up Desmos is that now I know what that graph looks like. So the graph that matches it is this one. I think I like that. Okay. But we don't need to look at it until we get to that part. So, here, next problem. We did 13 parts, y'all. Follow the steps for graphing a rational function to determine the function of the graph. Cannot be factored further is not true on this one because we can factor the top and the bottom, because right here I can factor a 5 out and end up with x plus 1 because 5 goes into 5. On the bottom we can factor a 9 out and I'd end up with x plus 3. So that's what we're going to type on this one. The reason they want us to do this is because it makes it simpler when we're finding intercepts and asymptotes and all the things, and domain. So our domain here, when we solve this, take your denominator, set it equal to 0. So I'd have 9 times x plus 3 equals 0, and I'd set it equal to 0. Does 9 equal 0? No, it's gone. X plus 3 equals 0, so x equals negative 3. This is also our asymptote. I don't want it all. So our vertical asymptote because we're gonna need this later, is x equals -3. So when we go to type in our domain, they want this in interval notation, so it's gonna go -infinity to -3, unioned with -3 to infinity. -infinity to -3, unioned with -3 to infinity. Okay. And then I already wrote that vertical asymptote up there that we just found. This is in lowest terms though, because even though we factored it, we can't, like if this would have been 3, we could reduce this 3 and 9, and that would reduce and simplify. Nothing does though, because 5 and 9 don't. X plus 1 and x plus 3, I can't make those reduce more. So locate the intercepts of the graph, select the correct choice, and if necessary, fill in the answer box. So first let's do y, and we'll put 0 in for x. And you don't have to use your factored one on this. I could have put it into the other one and it probably would have been easier. Because here I'm going to have 5 times 1 and 9 times 3, which is going to give us 5/27. So it might have been easier to do that. Because when you put your 0 into those x's, they're gone. So that's our y-intercept, 5/27. And then let's go ahead and get our x-intercept. So we do 0 equals, and if you remember, the first step would be to multiply by the denominator, and anything times 0 is 0. So I'm going to do 5x plus 5. And I would subtract 5 first, so I'm going to have -5 equals 5x, then divide by 5. So -1 equals x. So I have an x and a y-intercept, so we're going to use this one, and I'm going to have -1 and 5/27. Onward. Don't need to get rid of that. Determine the behavior of the graph at any of the x-intercepts. So our only x-intercept was that one at x equals -1. Where that x equals -1 occurs is right here. This is where we look for that multiplicity. So is there an exponent with this x plus 1? No, so that means it would be 1, and at 1 it crosses, because that is our multiplicity rules. And they already have the x equals, so we just type -1. Vertical asymptote, we found that. There, we just had 1, so not 2, not 3, just 1. You have to type the equation, so x equals -3. Then we're on horizontal right. No, hole in a graph. So remember, hole in our graph would be if two of our factors lined up, and we have x plus 1 and x plus 3. They are not the same, so there's no holes. Determine the behavior of the graph on either side of any of the vertical asymptotes. So our vertical asymptote is x equals -3. That one would be right here. So what is our exponent here? None, so it is 1. So that's odd, and at odd it crosses, so they're going to approach infinity on one side and -infinity on the other. Option A is if you have 2 and they're opposite. B is if you have that even multiplicity, and C is my odd multiplicity. Remember though, they can mix these up. I'm just telling you on mine right here, that's the order, so be sure you pay attention. So we're starting our second video, so this is already over 30 minutes, but it's fine. Okay, so we're doing our horizontal asymptote now. Horizontal or oblique, we're figuring that out. The first thing we have to do when we're figuring out our horizontal or oblique asymptote is to find the degree of the numerator and the denominator. Before I realized it timed out, I'd done this. So our numerator, our x does not have an exponent, so our numerator's degree is 1. We have an x in our denominator, so our degree is also 1. And then we pull up our handy dandy table. And numerator and denominator are equal because they're both 1. And it tells us to take the leading coefficients of both and simplify for horizontal asymptotes. So we have a horizontal, which means we do not have an oblique. So our horizontal asymptote is those leading coefficients, which means whatever is with the highest x, the degree, like if I had an x squared, it'd be what's with it as well. So we'd look at our x's and it'd be the 5/9. It's also what we factored out here, but double check. So 5/9, and since it's an equation, we're going to type in y equals 5/9. We had a horizontal, so we do not have an oblique. And then they're going to ask us if that intersects our graph. So we're going to put 5/9 in for y and solve for x. So where do I want to do that? 5/9. I'm deciding if I want to use our factored one or our unfactored one. Let's do the unfactored one and see where we get. So our first step when solving this, because we're solving for x, we're going to get it all on one line. So we're going to take this denominator and multiply it on both sides so that this one will become 1. Anything divided by itself is 1. And here 9x plus 27. The other day when I did this in class, it confused them a little bit, so I'm going to be sure to talk more about it for y'all. I'm not going to multiply everything by 5 just yet. I'm going to bring my 5 down. I'm going to divide this by 9 though. So when I divide it by 9, 9 divided by 9 gives me just 1x there. 27 divided by 9 gives me a 3 here. And then my denominator's gone here, so I have 5x plus 5. I'm going to distribute this 5 here, so I'm going to have 5x plus 15 equals 5x plus 5. When I move my 5x's to get them on the same side, since they're both the same, they both become 0, and I have 15 equals 5. Does 15 equal 5? No, it does not. Since that is not true, there is no point at which the graph of R intersects. If it was true, if I had 15 equals 15, that would be that infinitely many points. But ours doesn't do that. Use the real zeros of the numerator and the denominator to divide the x-axis into intervals. Determine whether the graph of R is above or below the x-axis. Choose the number in each interval and test. This is where we went ahead and pulled up our Desmos graph and checked it. So let's change this to match that. F of x equals 5x plus 5. Oh, I need to go back. Okay, 5x plus 5 over 9x plus 27. Okay, now then I'm going to scoot this over. Get rid of that. Our intervals right here. This is our first one, negative infinity to that asymptote right there at -3, and that is all going to be above. And then we're going to have negative, there's another one right here, y'all, because we have to take that x-intercept into account, and our x-intercept was, when we factor out the 5, we have 1. So this is going to be -3 to -1. And that -3 to -1, that little bit right here, that's below. And then from -1 to positive infinity, it's back to being above. Can you all see that? Is that okay? So all of that is going to go here. Let me do this too for this part. Guess I swapped them, but it's okay. Back to this part. So is above the x-axis on negative infinity to -3. Use a comma to separate them. -1 to infinity. It's also above, and then our only little section that was below is -3 to -1. And then which graph matches this? I can take off my stuff. We can look at it. Nope. Nope. Yes. Last one. Is it in the factored form? It is not all the way factored because right here, that's the difference of two squares, and it splits up because there's a square root of 9, and that means there's two factors of 9 that subtract to get 0, and that is 3 and 3. But one has to be positive and one has to be negative to make 0. So this is our factored form. What is the domain? So we take our denominator and set it equal to 0. And x plus 3 equals 0. So I'd have x minus 3 equals 0. And x plus 3 equals 0. So I'd add my 3 here. X equals 3. And -3. And then remember that those are our vertical asymptotes because they cannot be included in the domain. And when we type this all out, negative infinity to positive infinity, so negative infinity to the smaller one, union. Make sure I didn't hit a period in that. Okay. Is it in lowest terms? Yes, because nothing matches each other on the top. It does not reduce anymore. X-intercepts and y-intercepts. So y-intercept, we set our x is equal to 0. I'm going to use this one. 0 squared minus 9, which is going to leave us with -4/9 as our y-intercept. Then when we do our x-intercept, we'd have 0 equals 4, and we'd have x squared subtract 9. But when we go to solve this, we'd have to multiply by x squared subtract 9. And when we do that over here, it'd be anything divided by itself is 1. Anything times 0 is 0. Does 0 equal 4? It sure doesn't. So we do not have an x-intercept. So -4/9 is our y-intercept. Why do I have splitting? Determine the behavior of the graph at any x-intercepts. We did not have an x-intercept, we just have a y-intercept. So that makes this one easy. Vertical asymptotes, we have those. We have 2, so pick the option that has 2. Our leftmost is x equals -3. Our rightmost is x equals 3. We have no holes in our graph. We don't even have an x in our numerator to be able to act like we could. Vertical asymptotes. So looking at the multiplicity on these, they are both 1 because we don't have an exponent there, so that means it's 1. So it's going to go to -infinity on one side and +infinity on the other because it crosses. So it's not this one that has both. Even though we have 2, both of ours are multiplicity 1. Approaches infinity or -infinity on both sides. That's your even multiplicity. So right here, and they already have x equals, so we're going to do -3, 3. Figuring out horizontal and oblique asymptotes. So the degree of our numerator right here, there's not an x, so the degree of the numerator is 0. The degree of our denominator is 2. So we have 0 and 2. Let's look at our chart. 0 is less than 2, so the line y equals 0 is a horizontal asymptote. So we have a horizontal at y equals 0. We have no oblique. No oblique. The graph intersects the horizontal or oblique asymptote at. So when the horizontal, it was at y equals 0, so we put 0 in for y. And we've done this once. And solve for x. And when we do that, you'd multiply by x squared minus 9 on both sides when you solve it. Here, anything times 0 is 0. Over here, when you divide by the same thing, it becomes 1. 0 does not equal 4. So we do have the asymptote, but there is no point at which the graph intersects it. The other one's infinitely many, and then the last one is the value if they do cross. Use the real zeros of the numerator and denominator to divide it into intervals. So this is where we've been using our graph. So let's go ahead and pull that up. I know what I need to do. And let's push this over. We're going to change it to f of x equals 4 divided by x squared. Okay. And push that back over. Scoot our graph over. So we know from our domain, because we didn't have any intercepts, this is going to be negative infinity to negative 3, and it's above. Right here is our negative 3 to 3, and then this is our 3 to infinity. So, above, below, and the graph is below the x-axis, above. Negative infinity to negative 3, comma, 3 to infinity. And then it was below on the interval, negative 3 to 3. Which graph matches it? That's the opposite. This is it. And that is all, because this one had that synthetic division oblique asymptote, and we are not.